Hi, everybody. It's Mr. Kaiser here, and I want to talk to you today about how to name polyatomic ions. Let's get into it. So, when you're doing nomenclature, you really are just having to decide whether you're going to name ionic or covalent compounds. And we're talking about naming ionic compounds that have polyatomic ions. Okay? And so, when you name ionic compounds, you just have to name the cation and the anion. And quite often, the anion is a polyatomic ion. There is one cation that's polyatomic, and that's the ammonium ion, but the majority of them are anions. So there's a ton of polyatomic ions out there, and you often see them listed in tables like this one. So this one has about 36 polyatomic ions listed. And if you're being asked to memorize them, which in my class you are being asked to memorize them, this can be pretty daunting. Every single one of these has a the element it's composed of. So you have to memorize NO3 plus the charge. So NO3 negative is the nitrate ion. NO2 negative is the nitrate ion. And they all seem to be sort of disjointed from each other. Fortunately, there's actually a system to how these are named. And I learned in high school, and I teach to my students also a system for how to learn the majority of these, and actually even more than the ones that are on here. Some of them aren't a part of my system, but most of them are. So I'm going to teach you the system now. So you should have this sheet handy. It's called oxyacids and their derivative ions. And we're going to fill this in. As we go along, I'm going to teach you how to memorize the names of probably close to 40, maybe even more polyatomic ions, and the system for how to do that. In order to memorize this, you just have to remember that clowns never con smart people, and this number, 11223333344, as well as a system that goes along with it. Let me show you why you need to memorize clowns never con smart people and those numbers. Here's how it works. You write clowns never con smart people. The phone number to memorize is 112233334. And then we fill in hydrogens and oxygens for the rest. H down this column, and O's down this column. And what you have is the correct formula of 5 oxy acids. They are chloric acid, nitric acid, carbonic acid, sulfuric acid, and phosphoric acid. Okay? So by memorizing clowns never con smart people and those numbers, you can write the correct formula of these 5 oxy acids. Now I'm going to teach you how to name their derivative ions. Okay, so we're going to go back to this sheet here, and you'll see that I have clowns never con smart people all listed down in the sort of more white rows. Okay. So by following the system, we can write the formulas for the oxy acids. Clowns never con smart people. We don't write the ones typically, but it'd be 1 by the chlorine, 1 by the nitrogen, and it goes 2, 2, 3. You have to forgive my marker's not always showing up. And it's 3, better than that, 3, 3, 3, 4, 4. And we're going to fill in the hydrogens. And the oxygen. Not working perfectly there. I'll go back, those are oxygens, and that's 2, and this is a 3. Okay. So now we have the correct formula for chloric acid, nitric acid, carbonic acid, sulfuric acid, and phosphoric acid. Okay, so we're going to keep on filling in the oxyanion and the formula for them. So to get the formula for the oxyanion, all you do is remove hydrogens. You remove all the hydrogens that are there. That's how we're going to start. Okay. So if I remove the hydrogen from ClO3, I'm left with ClO3. Every hydrogen I remove, it leaves, because it's an acid, it leaves with just the hydrogen, the proton. It doesn't take its electron with it. So we're left with a negative charge. Okay, remember, it's an anion, so it's a negatively charged ion. And the quantity of charge is the number of hydrogens you removed. So there's one negative charge on this ion. So if we started with chloric acid, okay, it's an ic name, it's going to give us an 8 ion. So we're going to change the ic for an 8, and it's called chlorate. This is the chlorate ion. Okay, so again, taking it back to, like, why are we doing this? If somebody says, I've got sodium chlorate, you're like, chlorate, gosh, what's that? Well, it's ClO3 with a negative charge. So you can do the cross-down method and find the formula for sodium chlorate. Let's go down to the next one we did, which is this nitric acid. We're going to remove the hydrogen from it. There's only one hydrogen there, so we left with NO3. And it's going to have one negative charge. Okay, I get that 3 down properly, but it's not writing it very well. There we go. We took off one hydrogen, so we have one negative charge. That's part of the system. Nitric acid becomes the nitrate ion when it loses its hydrogen. If you've ever heard of nitrates, now you know what they are. NO3 with a negative charge. Okay. Let's go to the next one, carbonic acid. So that's going to give us CO3. Since we removed 2 hydrogens, we're left with a 2 minus charge. I'm going to try writing that a bit better. CO3, 2 minus. Okay. And what's the name of this going to be? Well, it's going to be called the carbonate ion. Carbonate. Terrible. I wonder if I can make this a little bit bigger. Let me see. View. Oh, there it was. Zoom. Just one time. Let's see. Let's go to 150. There we go. That'll help me a little bit. All right, so that's carbonate. Good. All right, let's go to the next one, H2SO4. So this will give us the SO4 2 minus ion, right? 2 negative charge because 2 hydrogens got lost, and it's going to be called the sulfate ion. You can write it with an F or a PH, it doesn't matter. And phosphoric acid is going to give us the phosphate ion, which is PO4, and it's going to have a 3 minus charge because we removed 3 hydrogens. Phosphate. All right, so now you know, you've memorized, right? Because you know clowns never con smart people and the numbers. You can write the correct formula of all of these acids, chloric, nitric, carbonic, sulfuric, and phosphoric acid, and you can easily turn them into their derivative oxyanions. The chlorate ion, nitrate ion, carbonate ion, sulfate ion, and phosphate ion. You can name them, and you know their formula and charge. Okay? The charge, remember, is simply the number of hydrogens you took off. Okay, so now the system continues. So it turns out that with the clowns, or the chloric acid, that you can have versions with extra oxygens and less than the normal number of oxygens. But we start with 3, O3, right? That should be a bit clearer there. That's a 3. Okay, that still didn't make it very clear. There we go. Okay, so if we add an oxygen, it's going to be HClO4, right? We've got one more oxygen. And if something has an extra oxygen, it's called the per something. So this is perchloric acid. You've heard of hydrogen peroxide? Same thing. Okay, so this is perchloric acid. Hydrogen peroxide is H2O2. It's got an extra oxygen to regular hydrogen oxide. This gives us the perchlorate ion, which is ClO4 with a -1 charge. The system hasn't changed, right? We're just going to take off one hydrogen and have a 1 negative charge. Okay? So that's the perchlorate ion. Just have to remember that per means one more oxygen. You can also have one less oxygen. That would give us one less than the normal one, the 3. Okay, so it's HClO2. And for this one, the ic suffix gets turned into an us suffix, an OUS. This is called chlorus acid. By the way, that system is used here when we lose an oxygen, and here, and here. So it's not like, oh, this is so random. It's not random at all. We're going to lose an oxygen, and the ic changes to an us. Okay, so that's chlorus. Now, what do we call the ion? Well, instead of 8, if it's lost an oxygen, it's the ite ion. So this is chlorite. Us changes to ite. Ic changes to 8. And the formula is going to be ClO2 with a minus charge. Okay, apparently I can't write a 2 there. So that's just the way that is. There we go. All right, there's one more for this. You can also, with the clowns only, with chloric acid only, you can lose 2 oxygens. And that gives us HClO, right? We've gone from 3 minus 2 to 1. So there's only 1 oxygen there. It's still called chlorus, but because it's less than, we call it hypochlorous. Hypo means below or less than, like a hypodermic needle goes below the dermis, the skin. This is hypochlorous, one word, okay? Hypochlorous, and guess what the oxyanion for that is? Well, us becomes ite, so it's the hypochlorite ion. And its formula is ClO minus. Okay, which incidentally, hypochlorite ion, if you look at the ingredients on bleach, you'll find that it's sodium hypochlorite. That's where that one comes up. So you might think, oh, cool, I've just learned a system for these 4. But in fact, you have learned the same system for 16 different ones. And that's because the same principle applies to all of the halogens. So you could do this same thing with fluorine, chlorine, which we just did, bromine, and iodine, right? So fluoric acid is HFO3, and the fluorate ion is FO3 minus. Or you could have bromic acid. You could have bromous acid. You could have the hypoiodite ion. That would just be IO3 negative. So you can replace the chlorine with any of these, and then you just replace the chlor part of the name with fluor, bromo, or iodo. So actually that gives us 4 times 4, 16 polyatomic ions, and they're oxyacids as well that you've learned how to name. You just learned how to name 32 things. Pretty good. Well, let's move on. We already know nitric acid and the nitrate ion. If you lose one oxygen, you should already know how to name that. Ik goes to us when it loses an oxygen. This is going to be called nitrous acid. And it's going to be HNO2. One less oxygen. The formula for it, you should also be able to guess. Sorry, not the formula. The name of the oxyanion, us, goes to ite. So it's nitrite ion, which is NO2 with a negative charge. Same thing for sulfuric acid. When we lose one oxygen, it becomes sulfurous acid. Sulfurous acid. You've got room to write the word acid in there. Go for it. Formula, H2 stays the same. SO3, because it's got one less oxygen than the standard clowned one, right? And what we're going to call the ion, we'll call it the sulfite ion, and its formula will be SO3 with a 2 negative charge. I guess I should point out that carbonic acid, there's no such thing as carbonous acid. It's not like I forgot to put them in. It's just that the halogens can all gain one or lose two. So there's the most variation with the halogen. For nitric acid, sulfuric, and phosphoric, they can all lose one oxygen. They can't lose two or gain one. Carbonic acid, that's all there is to it. There's no other variance in terms of number of oxygens. Okay? So this table is comprehensive. Then we got the people. Phosphoric acid, we can lose one oxygen, H3PO3. I just lost my ability to write here. Moment. So there we go. And that will be called phosphorus acid. Sorry about the messiness. Phosphorus acid. And the ion will be PO3 negative. Not write a 3 very well there, apparently. Yeah, not going to work. And it's going to be called the phosphite ion. Okay, so this table is full. If you count up all the ions you've learned, it's quite a lot. But it's not all. We can go further with this system. Unfortunately, I'm not able to expand the table to pull in the variations on hydrogens. I just have to do them below the table. But if you look at carbonic, sulfuric, and phosphoric acids, you'll see that they have 2 or even 3 hydrogens there. Why do they have to lose all of them? They don't have to lose all of them, right? So here we've made them lose all their hydrogens. So they have 2 negative charges and 3 negative charges. But what if they only lost one of their hydrogens? Or for phosphorus or phosphoric acid, they could lose 1 or even 2 of their hydrogens. Well, for that, we've got this part of the table down here. Okay, so let's look at hydrogen carbonate for a second. If the carbonate or carbonic acid, which we started out with, only loses 1 hydrogen, it'll look like this, HCO3. Now remember, the number of hydrogens you lose is the amount of negative charge you've got. So if we lost 1 hydrogen, we're only going to have 1 negative charge. And that's the formula and charge of the hydrogen carbonate ion. The nice thing is, the name kind of is the formula, right? It's a hydrogen carbonate with a 1 minus charge, as opposed to a carbonate, which has a 2 minus charge because it lost both hydrogens. Incidentally, for these guys here, the common name, not the IUPAC name, but the common name replaces hydrogen with bi. Right? So this will often be called the bicarbonate ion. And if you look at the ingredients on your baking soda, it'll say it's made of sodium bicarbonate. Same with this is called bisulfate or bisulfite. Okay, let's look at the next one, hydrogen sulfate. So the sulfate ion is SO4 minus, but if it only lost one hydrogen, it would be HSO4 with a 1 negative charge. And that's because it's only lost one hydrogen. Hydrogen sulfite, well, we already know the sulfite ion. Here it is. So if it only loses one hydrogen, it's HSO3. The minus charge. Now with phosphate, we have 4 variations, and that's because phosphoric acid has 3 hydrogens. So we've already shown what happens when it loses all those hydrogens. But what if it only lost one hydrogen? What if it lost both hydrogens? Well, here we have hydrogen phosphate, which is going to be HPO4. That hasn't changed. It's only got a single hydrogen because down here you can see we're going to have 2 hydrogens. So hydrogen phosphate has 1 hydrogen. It used to have 3, so it must have lost 2 hydrogens. So it's got a 2 minus charge. Same with hydrogen phosphite, only being an ite. It's got 1 less oxygen. And also a 2 minus charge. Dihydrogen phosphate, just like it sounds, H2PO4. Now, compared to H3PO4, it's down a hydrogen, so it has a negative charge. Dihydrogen phosphite is H2 dihydrogen PO3 phosphite, and it only has 1 negative charge as well. Okay, so again, we can use the same clowns never caught smart people with the phone numbers, and we now know all these variants. There's 7 more here, plus the 16 up here, 7, 8, 9, 10, 11, 12, 13. There's a lot of polyatomic ions that you've just memorized. There's a few others that you should know, and this means memorize. You're going to come across them quite a bit. Memorizing them means you know their formula and their charge. The hydroxide ion, OH minus. The acetate ion has 2 formulas. You'll come across both of them. One of them is C2H2O2 minus with a negative 1 charge. The other one is CH3COO minus. Jakku. Both are acceptable. They just highlight different things. One of them shows just the atoms that are present. That's this one here. Tells you that there's 3 hydrogens, 2 carbons, 2 oxygens. It's negatively charged. This one tells you a bit about the structure. Okay, because the arrangement of these, I guess I can draw it for you down here. It looks like this. There's 2 carbons bonded together. This one has 3 hydrogens on it. And this one is double bonded to 1 oxygen and single bonded to another one, and they have a negative charge sustained between the 2 of them. Okay, so that's where you get the CH3COO negative. That's this formula here. This one doesn't tell you anything about the structure. Okay, so the acetate ion, it comes from vinegar, so it's very common. Acetic acid is another name for vinegar, and by the way, there you have that same structure, right? The ic acid gives the 8 ion, so acetic acid gives the acetate ion. So what's the formula for acetic acid? Well, just add a hydrogen until you're out of these guys, and you put a hydrogen here, and you've got yourself acetic acid. Okay, the ammonium ion, you got to know that one. It's the only positive one that we're really going to be encountering. It's NH4 plus. You may also encounter these ones. I'm not really asking you to memorize them for this course, but there are other courses where you may memorize them. So cyanide ion capital C, capital N. Yes, it's poisonous. It has a 1 minus charge. Permanganate. You'd recognize that 8 ending. Oh, that must come from permanganic acid. Permanganate ion is Mn, manganese, O4, with a minus charge. The chromate and the thiosulfate, I encounter them so little that I should look them up myself, but I believe they're going to be here. Let's find them. Are they in there? Chromate. There's a chromate and a dichromate. CrO4, 2 minus. CrO4, 2 minus. And the thiosulfate. Did that show up here anywhere? There you go. It's not even on this table. They've got sulfate and sulfite, but not thiosulfate. I think thiosulfate means like an extra sulfate or something, or an extra sulfur. I'm pretty sure it's S2O3, 2 minus. Could be wrong, so make sure you check that up. Is it over here? Oxyions. This is on the back of that sheet. Thiocyanate. See, thio means an extra sulfur. Anyways, I don't see it there. Okay, that fills this sheet, and you now know the system. Let me put it into action for you. So on this page, I showed you how to set it up, and maybe I'll just get rid of all this and do it one more time for you, so we can start at the beginning. Okay? So let's say you're asked to name something with a polyatomic ion. You go, oh my goodness, I don't know what to do. Well, how would you dump this at the beginning of your page? You go, clowns never con smart people. The phone number, 11223333344. Put in the hydrogens. Oops, that's not a hydrogen. Getting ahead of myself. Oxygens. Now you've got the formulas of all these 5 oxy acids. Let's say somebody asks you, okay, I want the formula for sodium phosphite. And you're like, ooh, sodium phosphite. How do I do that? Well, you got to use a cross-down method to figure out the correct formula of this thing. So if sodium has a +1 charge, you can find that on your periodic table. But the phosphite ion is not going to be on your periodic table. It's going to be related to this one. You just have to remember that ite, it means 1 less oxygen. So instead of PO4, it's going to be PO3. You also need to know its charge, and its charge is the number of hydrogens it lost. It used to have 3 hydrogens, so it must have a 3 minus charge. Now you can cross the 1 down to there, so your formula's got a PO3 with only 1 of them, we don't write that, and the 3 crosses down to the sodium. Na3PO3, sodium phosphite. That's just one example of how you can use this. Of course, like I said, we've already, with just these guys, you've memorized 30 to 40 different polyatomic ions. So that's pretty good. All right. I'm going to say that that's pretty good for this video, and hopefully that was helpful to you. If you got any questions, be sure to email me or talk to me in class. All right. Talk to you later.